Hello and welcome back to Calculus 1. This is exam 2 review, which is next class, right?
Yeah.
Which that means that I have to make the exam tomorrow. Okay, fine. I'll bring something in. You know the drill. 10 problems, hour and 20 minutes, all the specs. We are focusing on chapter 3, and with chapter 3 we also have to know the limits, right, because of the first section, and then after that we have all the derivative rules and all of that good stuff. So let's take a look. So we are focusing on chapter 3 in exam 2. We're talking about 10 problems, right? 100 points. You have the prep quizzes going already for some time. There are 3 quizzes left, one tonight, one tomorrow, and one on the day of the test. So 3 quizzes left for you to practice. Also the practice exam that it's there in my MATLAB. So take a look at chapter 3 post-test that is covering the entire chapter 3. Now, if you are asking me to single out one thing for the entire chapter 3, that's going to be the tangent line. If you ask me to, like, if I am to write a list of all things, which I will, and if I had to put one thing in red, then that will be the tangent line. So, number 1, tangent line. Because this problem takes our chapter. You must take the derivative to compute the slope, right? That derivative could be basic, product rule, quotient rule, chain rule, logarithmic differentiation, implicit, right? Could be anything from chapter 3 within the tangent line. So the tangent line is one problem that kind of canvases over the entire chapter 3. If you're asking me for my favorite, well, what do we have for my favorite?
311.
311, exactly. My favorite, 311, the word problems with related rates, which I'm going to put here as number 2 in red, related rates. Please remember that related rates are pretty much the only way you're making money from this chapter. Now, what else do we have? Well, we have a limit definition of the derivative. Limit definition of the derivative, if you don't remember it, that was the limit h goes to 0 of f of minus f of x over h. And you're supposed to crank that on a polynomial or a square root or something like that. Nothing too complicated.
Are we going to have to do that, or is it just going to be a question, like say the definition?
No, you're doing the problem because you are creating the difference quotient and then you're running the limit calculation to actually come up. Now, the good thing is that you know what the answer is supposed to be because you can take the limit the other way. The question, so you don't have any issues with this, is let's say 10 points. The answer is 2 points. So the work with limit and creating the function is 8 points. So if the question says find the derivative using the limit definition of the derivative, I find the derivative of, I don't know, square root of 3x, and you just go, oh, I know what the derivative of this is. It's 3 over 2 root 3x because you know the chain rule. Well, all I can do is assign 2 points out of 10 for something like that, because you are supposed to use the limit, not other stuff. So now we have derivatives. What do we have? We have basic, Chain rule. We have product rule. Quotient rule. No, it just works fine over here. A logarithmic. Wow, right? Patience, young Padawan. And what else do I have? An implicit, thank you very much. Now, we did talk about trigonometric. Well, they're under basic, right? Inverse trig, don't forget the inverse sine, inverse tangent. Those are very important, right? The other ones, they don't usually show up, but those first two, right? Inverse tangent and inverse sine, they will pop up in your Calc 2. They will pop up in differential equations. So I expect you to know those better than the other four, right?
Which ones?
Inverse sine, inverse tangent. Inverse tangent being the boss, followed by sine, followed by the other four that I've never seen any problem them after Calc 1. So, guys, this is whole thing on taking derivatives, right? If it says use the product rule, use the product rule. If it doesn't specify technique, use whatever, right? That's that. Number 5. What am I missing? I'm missing something. Test. Well, actually, that's it. Oh, derivatives as rate of change. No, that time derivatives are related rates. Derivatives as rate of change was, you have a position function, you take the derivative, you get the velocity, you take the derivative, you get the acceleration function, you set velocity function equal to 0 to find the time at which the maximum happens. We also had that the business problem when we did the marginal cost, average cost analysis to figure out whether production was set up well and whether we should keep our business model, right, or change stuff in the factory and so on, right, which is what Musk is dealing with constantly with his Tesla production. Model 3, headache from day one, still going on. So that's those. Please observe that the tangent line and related rates are red. Any exam 2, 3 final without tangent line is a garbage exam. I don't care who wrote it, because tangent line is the focus of Calculus 1. Tangent line measures the change. Tangent line is the derivative, right? The slope is the derivative at the point. So if you are measuring the change, that marginal cost is the slope of the tangent line, making tangent line the most important problem of chapter 3 and making it one of the most important concepts of Calculus 1. So I'm telling you that the tangent line problem will show up on exam 2, exam 3, and the final exam. Now, in the process of tangent line, you are taking the derivative, and that derivative is going to be one of the derivatives from the list. Tangent line to x squared, great, 2x you're going on, right? Tangent line to ln x, great, 1 over x, and you go on. But it could be implicit differentiation, because, and we have examples that we've done in class that are tangent lines done on the implicit. You can use logarithmic, you can use pretty much anything, well, not pretty much, you can use anything as a function as long as you can take the derivative of it. Related rates. We did talk in class about related rates. we know that there are triangle problems, area problems, volume problems, right? All of these different types. As you figure out the geometry, you will take the time derivative of it, and you will observe the change in time. Related rates, in which way the volume grows in connection to, let's say, an area. Surface area. Can you do that? Sure you can, right? You have the surface area of the object and you have the volume, and you just need to connect them to the formulas. Say you have a cube with the side A, whose volume is A cubed, and surface area surface area A is 6A squared, because you have 6 faces on a cube. Each face is A squared, so the total surface area is this. Is there a way to write a formula so that these are connected? And the answer is yes, right? You can connect these formulas through A. You can write volume is equal to A times A squared. Over here, over here, A squared is equal to area over 6. And now you plug that in. And what you get is volume is equal to A over area over 6. So there you go. Volume is 1 over 6 AA. It's a product rule. And now you can take the time derivative. And you develop related rates where the volume is going to be given in terms of change in area. You can connect anything as long as you're able to combine formulas on some level. Now, physics is the best place to learn that kind of stuff, because pretty much every problem in physics should involve manipulating these formulas and putting them together. To some extent, general chemistry would give you the same. To some extent. Physics is the place to do this stuff a lot. So now, when I take the time derivative, I get dv dt is equal to 1 over 6. That's a constant. And now I have a product rule. Because if this is an ice cube and I leave it to melt, the edge, which is a little a, is going to decrease, and also capital A, which is the area, is going to decrease. So they're both variables. And I do the product rule. So that's A, dA dt, that's the change in area, plus A, and now dA dt, which is the change in side. Good effort over there. And finally, you can bring in, if you want to eliminate any. So this would be your related rates. And you see that a lot of stuff is related here. Change in volume, change in edge, change in area. You can reduce amount of variables by taking the time derivative of this. Maybe. Right? Because if you take the time derivative of this, you get to have dA dt equals to 12a dA dt. So now, with this equation, right, you can replace dA dt over here by this, which will eliminate that as a variable. Or you can eliminate this as a variable if you don't have it, as dA dt divided by 12a. There's always something that, somewhere. So this is just one of the examples that I tossed on because, you know, it's a nice exercise which tells you, you know, you can combine equations together. Now, obviously, the cheapest problems are the soda can, right, which R is constant, so you don't have to worry about it as a variable. Something with the ball. We did the snowball rolling and picking up volume. I think in a book they have this, the weather balloon gets inflated, so it becomes bigger, right? So that's cool stuff, yes? Nope, you know those because we talked about the volume, right? We break everything into 3 categories. We have a category for prism, so cylinder or any kind of a prism like this, including more sides or whatever. They have their volume to be area of the base times the height. So area of the base. And then we have those spiky objects, which is the cone, and then the pyramid, and so on. So if they have a spike on the top, volume is 1/3 b times the height. And then we have the perfect one, sphere, volume is 4/3 pi r cubed. And these are covering all of your geometry for volume. All of it is there. Just have to see which one of these it falls into. But you always have the area of the base, because the base is what? It's a square or it's a circle, and you need to know area for square, circle, triangle, right? So if you have the area for the base, multiply by height of the object, and then when you multiply that by height of the object, what you do is, if it's spiky, times 1/3. If it's not spiky, just leave it as is, b times h, and then you are memorizing 4/3 for the sphere, for the ball, 4/3 pi r cubed. That would be our, right. So this covers all of the volumes. Can you come up with something else? No, right? Because anything that doesn't fit these descriptions, you'll get to it in Calc 3, right? When you take and intersect objects and create something, right? You have the umbrella shape and you want to know what the volume of that is, right? The volume of the umbrella, which is the amount of air that umbrella will capture actually. That thing is called elliptical paraboloid. We have formulas in chapter 13 on how to find the volume for something like that. Like the bullet shape or rocket shape things or whatever. We can calculate the football, right? Right now you can only deal with the soccer ball and tennis ball, right? Which is perfect, but if you have the football shape, right? How do you find the volume of that, right? And how do you find the volume of an egg, right? Well, sure, you do the water displacement, right? You figure out, but then can you calculate? And the answer is yes, right? Take my Calc 3 class, that's what you get to do. That's one of the possible problems. You boil an egg and then go and figure it out. So,
Do you weigh it?
no, why? Boil it, transfer on a page, on a paper, and then figure out the functions, crank some integral to done. Nothing in 2 hours of life. Do what?
It's a long, hard boiled egg.
No, that takes about 10 minutes. The rest of the stuff, transfer it on a page, right? You make a nice grid, right? And transfer there, and you see which function fits through it, and then you make that function 3D. It's not a problem. One step after another, you figure it out quickly. So that's that. Do you have any questions, concerns, anything for Thursday? Now that you have, yes. You know that I don't have it.
Oh no, what other question that replaces the question?
Oh,
If the test is spicier, yes. If no, then no question. Depends on. But since I'm writing that tomorrow, I can't really answer. I don't know.
Oh, what about definition questions?
Well, you know that each one of my exams, maybe, I don't know if you know that each one of my exams, but I always have either state the formula or state definition or something. Like last time, I think you had maybe you have definition of function. I told you about that one, right? And then you also had, I think, 3 rules for continuity, right?
Yeah, vertical.
Yeah.
Oh, that was that too. Wow, I was really nice. Guys, we don't have really that stuff in this chapter other than name basic formulas for derivative, right? Like state the product rule or a quotient rule or a chain rule. Like there are no definitions like in chapter 3. I mean chapter 2. So, like if I want to make you do some writing on a test in the paragraph form, what is the procedure for tangent line, right? Then you have to write a paragraph like by hand. I first find the derivative, then I compute the derivative at the point, and that's my slope.
But then you gotta read it.
Yeah, I know.
Yeah, don't do that to yourself.
So, oh really? Or I can just put, 2 tangent line problems on it, see if you're gonna miss both of them. Yeah, apart from that, like theoretically, I don't really have any theorems or anything crazy to push. But you need to know the formulas. I mean, you can't really operate on the exam that's coming up if you can't do product rule. I mean, if you don't know the product rule formula, quotient rule formula, procedure for chain rule, and all these things. So, yeah, that's going to be there. Anything else?
Graphing derivatives. Do you have any of that?
Oh, the graphing. I don't know. I'll think of it. I'll if I don't have anything else to put in, I'll add that to it. It's a good suggestion. Yes.
This with the chapter 4.
Yes.
It's probably the easiest part of the whole chapter.
All right, guys. Yes, it's guys. It's absolutely entire chapter 3, every page of the book. That's exactly what it is. There is nothing omitted, nothing skipped. So that's what it is.